Hi there and welcome to another chemistry lesson. We're starting now on electrochemistry, an introduction video this will be, and so you are most welcome. Let's get started. Now, what is electrochemistry? Electrochemistry is the study, that is not nice. The study of the relationship between the flow of electrons in conductors. Okay, so remember, a conductive material is a material that allows electrons to flow through them. And the flow of electrons is called electricity, and chemical reactions. Okay, so what you'll find is that chemical reactions can cause a flow of electrons. For example, a battery is a good example. If you take it's actually called a cell. If you take a battery that you get from the shop, okay, when it is connected to a conductive material and the circuit is closed, then it will actually be causing a flow of electrons because there's a chemical reaction happening inside. Okay, so chemical reactions can cause the flow of electrons, and also the flow of electrons can cause chemical reactions. It can have the opposite effect. Okay, so for example, when if this is connected to what we call electrodes in a electrolyte solution, then because there is a flow of electrons, it causes some sort of reaction to happen in the electrolyte and the conductors. But more about that a little bit later. What I will go ahead to describe in this video is something called half cells. Okay, a half cell. Okay, so imagine we have a beaker, and I'm going to draw kind of a beaker. So there's my beaker, and not a great beaker, and inside my beaker I have a solution, and here's my solution. Now that solution is called electrolyte. It's called an electrolyte, or actually electrolyte is dissolved in an aqueous solution. So electrolyte is a compound that ionizes when dissolved into an aqueous solution. In other words, what we have here is a solution with ions in it. Okay, so let's say that there's that's not visible. Okay, there's ions in this solution. Okay, in other words, positively charged and negatively charged particles in this solution. Okay, typical example might be sodium chloride. So there's sodium, which are the positive particles, and chloride, which are the negative particles. Then in this solution I put another object. Okay, I put a solid object. There's my solid object in the solution, and it sticks out and this would be called my electrode. So we've got electrolyte, which is a solution of ionized particles, and then we've got an electrode, and that is a conductive or actually more accurately a conductor that connects the non-metal part of the circuit. Okay, we're talking about the flow of electrons in circuits, so of the circuit with the electric circuit. Okay, so in other words, there is going to be connected to this a wire, okay, that forms a complete circuit, and this electrode is a conductive material, first of all, and this conductive material connects the electrolyte with the wiring in the outside of the circuit. So this is what we call a half cell. So a half cell is when part of electrode, when part of an electrode is surrounded by electrolyte. And so it's one electrode that actually just lies in electrolyte, which is connected to the outside of the circuit. Okay, other than that, I'll explain only that what is the purpose of this? What are we doing here? Well, the point here is that the positive charges in the electrolyte solution, that's the cations. The cations are attracting electrons from the electrode. So they're attracting electrons from the electrode, and as a result it will pull electrons through this conductive material. Okay, now this will be connected to another half cell that will do the exact same thing. Now it just depends which electrolyte has the strongest pull. The electrolyte with the strongest pull on the electrons will be the electrode to which electrons will start flowing. Okay, it's a kind of tug of war, but we'll look at more of that in our next video. But this is just the idea of what a half cell is. So thank you very much for watching. We'll see you in the next video. We'll look at the standard reduction potential. It sounds intense, it's really not, but I'll